There is a tiny patch of sky that appears completely empty when viewed from Earth. No bright stars, no glowing nebulae, no obvious galaxies, just darkness. But years ago, the Hubble Space Telescope stared into that darkness and changed astronomy forever. It revealed that this seemingly empty region of space was not empty at all. Instead, it was crowded with thousands of galaxies, each containing billions of stars stretching back across cosmic time. For many people, the Hubble deep fields became some of the most profound images ever captured. They served as a reminder that even the darkest places in the sky are filled with worlds, galaxies, history, and light too faint for the human eye to detect. Now, the James Webb Space Telescope has returned to that legendary region. What it found makes Hubble's famous image seem almost unfinished. After nearly 100 hours of observing the same tiny patch of space, Webb revealed galaxies that Hubble could not see, faint objects emerging from the darkness, red galaxies hidden in infrared light, and structures that may help explain how galaxies formed and evolved over billions of years. This was not simply another deep space image. It was a second look through one of the most famous windows into the universe. And the longer Webb stared, the more the darkness seemed to dissipate. The Hubble Ultra Deep Field remains one of the most important images in the history of astronomy. Released in 2004, it was created from more than 11 days of Hubble observations focused on a single tiny region of the sky. Later, the Extreme Deep Field (XDF) pushed even further by combining years of Hubble data collected from roughly the same area. The idea behind the project was astonishingly simple. Point a telescope at what appears to be empty space. Wait. Collect light. Then see what emerges. What Hubble revealed stunned the world. The darkness was filled with galaxies, not dozens, not hundreds, but thousands. Spiral galaxies, elliptical galaxies, tiny red smudges, distorted structures, and ancient light from a universe far younger than the one we see today. It was as though someone had drilled a tiny hole through the night sky and discovered an entire universe hidden behind it. Yet the field itself is incredibly small, and that is precisely what makes it so extraordinary. The Extreme Deep Field covers a region of sky far smaller than the apparent diameter of the full moon. If you held a tiny grain of sand at arm's length, it would cover approximately the same area. Yet within that tiny patch, Hubble detected nearly 10,000 objects, almost all of them galaxies. That discovery revealed something profound. The universe is not merely vast, it is saturated with structure. Everywhere we look deeply enough, galaxies are waiting to be found. However, Hubble had its limitations. It observed visible and near-infrared light with remarkable clarity, but some of the oldest, dustiest, reddest, and most distant galaxies remained extremely difficult to detect. Their light had been stretched by the expansion of the universe. Their stars were hidden behind thick clouds of dust. Their signals were simply too faint, too red, or too deeply buried for Hubble to reveal completely. The question remained, what was still hiding in the darkness? Then Webb looked, and the answer proved astonishing. The James Webb Space Telescope did not merely repeat Hubble's observations. It examined the same region using an entirely different kind of vision. Webb was built to observe infrared light, the type of light that allows astronomers to see through cosmic dust and detect objects whose light has been stretched into longer wavelengths by the expansion of the universe. That makes Webb especially powerful when studying the distant universe. The farther away a galaxy is, the more its light shifts into the infrared part of the spectrum. For this new observation, Webb used two of its primary scientific instruments. MIRI, the mid-infrared instrument, observed the field at mid-infrared wavelengths, while NIRCam, the near-infrared camera, simultaneously collected near-infrared data. Together, these instruments created a view of the region that Hubble could never fully achieve. The observation itself was extraordinary. Webb spent nearly 100 hours studying this single patch of sky, the longest continuous observation it had devoted to one region at that point. That matters because deep field astronomy is fundamentally a battle against faintness. The longer a telescope observes, the more ancient and dim light it can collect. Galaxies that disappear in shorter exposures slowly emerge from the darkness. When Webb's image was compared directly with Hubble's, the difference was immediately obvious. Areas that appeared almost empty in Hubble's image suddenly contained galaxies in Webb's view. Objects that had barely been visible became brighter. Structures that once seemed vague and uncertain appeared with far greater clarity. Even the background itself seemed less empty. Webb revealed at least 2,000 additional objects that Hubble had never detected. That is perhaps the most remarkable part of the discovery. Hubble had already made this tiny region of space seem impossibly crowded. Webb showed that it was even more densely populated than anyone had imagined. Part of the reason lies in Webb's sheer size. Hubble's primary mirror measures 2.4 meters across. Webb's segmented mirror spans 6.5 meters, providing a light collecting area roughly 6 times larger. That means Webb gathers far more photons in the same amount of time. Faint objects become visible much more quickly. Dim galaxies appear brighter. Details emerge where Hubble could see only shadows. But Webb's greatest strength is not simply its larger mirror. It is its ability to observe the universe in infrared light. Some galaxies are not merely faint because they are incredibly distant. They are faint because the expansion of the universe has stretched the light into wavelengths that Hubble was never designed to observe. Others are wrapped in thick clouds of dust, concealing intense star formation within red, obscured systems. To Hubble, many of these galaxies appeared almost like ghosts. To Webb, they begin to glow. Among the thousands of sources detected in Webb's new deep field image, some of the most scientifically valuable are the reddest galaxies.